Anybody need to see a step over this?
All I
Yes.
see it.
Okay, so the z is 2.49. You look on the handy dandy z table, and you get the probability that a z is less than or equal to 2.49, and that equals 0.9936, right? It's a right-tailed test, so you have to subtract it from 1. So 1 minus 0.9936 is 0.0064. Right?
Yeah, just I come with my calculator like that.
You what?
My calculator is so funny.
Yeah. Okay. So, what is the conclusion? So we're going to reject if p-value is less than or equal to alpha, right? That's the rejection rule if you're doing the p-value method. Okay, so write down your conclusion. What is your conclusion? Okay, so is the p-value less than alpha? Is 0.006 less than 0.05? Yes. Therefore, what's the word we're going to use? Reject. Okay? We reject. And then you conclude there is. Some people said reject and then said there is not. Okay, so reject, there is enough evidence to conclude. And when you conclude, right, m is greater than 15. Right, and you can look up there, or you can look on the window on your screen. Okay. Any questions? So, yes.
You said subtract 1 because it's a right-tailed test.
Right.
Do you do the same thing if it's left-tailed?
So if it's left-tailed, if this was a left-tailed test, then the p-value would be 0.9936. Right, so say you did it and it was really a left-tailed test, but the z you got was way over here, 2.49. So the probability or the p-value would be 0.9936, and then you wouldn't reject it because it's huge, right? And we're going to work one of those in just a second. Okay, so the only time you subtract when it's a z is when it's to the right, right? Because it's the shaded area. Okay. Any questions on this one? No? All right. So next one. Same scenario, but I have a different z. So tell me what the p-value is and what is the conclusion. So what did you get for 1.58? I mean, I wrote it down. So 1.58 is point. Let's see, 1.58 is 0.9429.
So we get the idea.
So 1 minus 0.9429, and the p-value is 0.0571. Okay? And so what's the conclusion? If alpha is 0.05, what's our conclusion? Do we ever use the A word in here? Fail to reject. Okay, then we start off with there is again, there is not, right? There is not enough evidence to conclude that there's not enough evidence to conclude that what? That the mean is greater than 15. Right? There's not enough evidence to conclude the mean is greater than 15. Right? Okay. One more example. This was what method of rejection? The p-value, because you use the p-value to say whether you're rejecting or failing to reject. Okay, so the next one is critical value. So we have same scenario, z of 2.49. I changed the alpha on you, it's now 0.01. What is the critical value?
Mrs. Donaldson,
Yes?
you have 2 HOs instead of an HA.
Oh, you have to come by my office for
Candy.
candy.
Oh!
You have
Told
3
you, watch
pieces
out.
now.
I told you.
How awesome. Keeps us all on our toes.
Well, I guess
I thought I was
Yeah. You know, we want people like you in our office meetings. We had, I don't know if you guys knew Professor Browning. She was an accounting professor. She was so awesome at catching mistakes, typos and stuff. Sad day when she left. Because, you know, you never, when you write something, you always miss whatever. Spell check doesn't catch everything. You know, it's awesome to have people that can see all the details. What? Yeah, she's awesome. Yeah, so now I'll send her. Okay, you guys got it? So what is the critical value? What's the critical value? Should I pick somebody, or is somebody going to say something? You have no idea? Okay. So, what? Okay, so you're starting in at 0.01, right? Is this a right tail test or left tail test? right tail test, so that means I have 0.01 here, and so that means 0.99 there, right? So you're looking inside your chart, and you gotta be on the Z chart, not the T chart, right? Because this is the Z. Looking inside for the number, the Z score, closest to 0.99. And what
Wait,
is
how
it?
did she get .01?
So, don't give it
Oh,
What? Right?
I didn't see the alpha.
2.33, yay! So the critical value is 2.33, right?
So we look at the Z score closest to
You look at-
.99?
Inside here,
Okay.
right, for the number closest to 0.99. Right, so 2.33 is the closest to 0.99, right? Well, this is just one off, and this is two off.
Wait, so none of you went to the review session?
Okay? All right. So this is our critical value.
We do another critical value.
Beg your pardon?
We do another critical value.
Yeah, just a second. So, we got the critical value, but a couple of you guys, because I only put the rejection rule for the p-value on the board, a couple of you tried to use the p-value as the rejection. So, when are you going to reject or fail to reject using the critical value method? What's your rejection rule? In this particular case, you're going to reject if what? If your test statistic is, so this black part's the rejection reason, right? So you're going to reject if your test statistic is what? Yeah, in the area of rejection, so greater than or equal to 2.33. In your textbook, in this chapter, there's a bunch of blue charts. I don't know if you noticed. It might be hard to do it if you're scrolling online.
Wait, I'm confused.
So these blue charts in the text, one's on page 361. It goes through the rejection rules using p-value, critical
what page?
value, for T, for Z, and
360?
for the proportion. So yes, Natasha.
Why, if 0.99 we found 2.33, why is that in the shaded part, not the, why is it in the rejection part and not the 0.99 if that's how we found 0.99?
Okay, so this is non-rejection, and this is rejection.
Right.
Okay, and you're asking me,
We found the 0.99, we found the 2.33 with the 0.99.
right, so this is the critical value that separates the area of rejection from the area of non-rejection. So if you're this number or bigger, it's in the area of rejection.
So it's that line.
That's the line. That's the, if you're on this line or past this line, you're rejecting. Okay? On the line or past the line. Like for the p-value, it was greater than or equal to alpha. So it could be equal to alpha and still be rejected. So p-value alpha is the rejection line. Okay? But you have to be careful, that's why I'm referring you to the blue. If this was a left tail test, you would reject if the test statistic was less than or equal to minus 2.33.